Okay, so you're here with us on the deep dive because, let's be honest, you want to keep up with everything that's going on, all the breakthroughs, without spending hours and hours reading through dense research papers and articles.
That's right. And this week, well, you sent us an article that really caught our eye.
Yeah, this one's from Live Science. It just came out actually March 21st, 2025, so just last week.
Hot off the presses.
And the headline is Scientists Create Ultra-Efficient Magnetic Universal Memory That Consumes Much Less Energy Than Previous Prototypes. So,
Catchy?
it is catchy, right? And it's got us thinking, this could be a big deal. So we're diving in today to figure out a few things. First, what exactly is this new memory technology all about? And second, why should you care? And then we'll get into what this might mean for the future of, well, everything really. Our phones, our computers, even the huge data centers that power so much of the digital world.
Sounds good. Let's jump in.
All right, so let's start with the problem this new technology is trying to solve. And I think we've all been there, right? You're working on your computer, you've got a million tabs open, maybe you're editing a video or something, and suddenly
Everything slows down.
Exactly. It's like hitting a wall, and the culprit is often the RAM, the random access memory.
Right. RAM is like the computer's short-term memory. It's super fast, but it has limited capacity, and it loses all its data when you switch off the power.
Then you've got your long-term storage, your solid-state drive or hard drive, which can store tons of data even when the power is off, but it's way slower than RAM.
So what scientists have been working on is this idea of universal memory, something that combines the speed of RAM with the data retention of storage.
And can you imagine what that would mean? I mean, it would be revolutionary.
Well, absolutely. We'd be talking about lightning-fast computers that boot up instantly. No more waiting for things to load.
And think about things like video editing or 3D rendering. It would all become so much smoother and faster.
Not to mention the potential impact on things like artificial intelligence and machine learning, where massive amounts of data need to be processed quickly.
Now, the technology that's got everyone buzzing is called MRAM, Magnetoresistive Random Access Memory.
And as complicated as it sounds, the basic idea is actually pretty cool.
Yeah, the article describes it as tiny magnetic compass needles inside the computer.
And the direction these needles point, north or south, represents the ones and zeros that make up computer code.
It's kind of mind-blowing when you think about it, how something so small can hold so much information.
And the really neat thing about MRAM is that it retains that information even when the power is off.
Now, MRAM isn't a brand new concept. It's been around for a while, but there's been a major hurdle holding it back.
Exactly. The amount of energy it took to switch those tiny magnetic needles between a 1 and a 0 was just too high.
Yeah, the article mentions that this high power consumption made MRAM impractical for most devices.
It was like having a super fast sports car that guzzled gas like crazy. It was great for short bursts, but not for everyday use.
And this is where these researchers in Japan come in. They've figured out a way to dramatically reduce the energy needed to write data to MRAM.
And their findings were published in the journal Advanced Science on December 25th, 2024, just in time for Christmas.
That's a pretty good present to the world of computing.
It really is.
Yeah.
So what they did was develop a new component for MRAM devices that requires far less energy to switch those magnetic states.
So less energy, lower power consumption, which means longer battery life and faster processing speeds.
Exactly. And the secret to their breakthrough is something called a multiferroic heterostructure.
Okay. Now that sounds pretty complicated.
It is,
Yeah.
but the article breaks it down for us. It's basically a combination of a ferromagnetic material, which can be magnetized, and a piezoelectric material, which generates electricity when you apply pressure.
So it's like a 2-for-1 deal. You get magnetism and electricity in one package.
Exactly.
Yeah.
But the real magic happens because of an incredibly thin layer of vanadium sandwiched between these two materials.
Vanadium, huh? I'm not sure I've heard of that before.
It's a metallic element, and in this case, it plays a crucial role.
The article emphasizes that this vanadium layer is the key difference from previous MRAM designs.
You see, one of the challenges with older MRAM was that tiny structural fluctuations in the ferromagnetic material could make it hard to keep those magnetic orientations stable.
So like imagine trying to balance a plate on a stick, any little wobble and the plate falls off.
That's a good analogy. So this vanadium layer acts like a buffer. It smooths out those instabilities and allows for a much more reliable and consistent direction of magnetization.
So it's like adding a gyroscope to that plate to keep it stable.
Exactly. And to prove their concept, these scientists actually built a working prototype.
And they put it through its paces, right?
Oh yeah. They sent an electric current through these materials and successfully switched the direction of the magnetic state.
And the important thing is that the materials themselves didn't deform or change shape during this process.
right? Which is a big improvement over some earlier attempts. And even more importantly, the magnetic state remains stable even after they removed the electric current.
So that means they achieved a stable binary state, that 1 or 0, without needing a constant power supply to maintain it.
And that's the holy grail of universal memory, the speed of RAM with the data retention and storage.
Now let's talk about what this all means for us everyday folks.
Just imagine phones and laptops that are significantly faster, have way more memory, and all while using less battery power.
I mean, that would be a game changer, right?
Absolutely. No more worrying about your phone dying in the middle of the day or your laptop running out of juice during a presentation.
And think about the possibilities for things like virtual reality and augmented reality, which require a lot of processing power.
And it's not just about personal devices. Either this new MRAM technology could have a huge impact on data centers,
Those massive server farms that power so much of the internet.
right? By reducing the energy consumption of memory at that scale, we could see significant cost savings and a smaller environmental footprint.
So it's a win-win situation, faster, more efficient computing that's also better for the planet.
And on top of all that, the article suggests that this new MRAM could also be more durable than current RAM technologies.
Because there are no moving parts to wear out.
Exactly. It's like comparing a solid-state drive to an old spinning hard drive. One is much more likely to fail over time.
So we could be looking at devices that last much longer before needing to be replaced.
Now, of course, every new technology has its limitations, and the article does mention one important caveat.
The researchers didn't specifically study how the efficiency of switching the magnetic state might degrade over a long period of time.
So it's kind of like with rechargeable batteries. We know they lose capacity over time after many charge cycles.
So more research is needed to see how this new MRAM holds up over the long haul.
But even with that unknown, this new MRAM technology represents a major step towards more efficient and powerful computing.
It's like we're on the cusp of a new era in computing where speed and energy efficiency go hand in hand.
And that's pretty exciting to think about.
So as we wrap up this deep dive, what's the key takeaway for our listeners?
Well, I think it's this. By overcoming the energy limitations of previous universal memory prototypes, these scientists have opened the door to a future where our devices are not only faster and more capable, but also far less power hungry.
And that's something we can all get behind, right?
Absolutely.
So here's something to ponder now that we've laid out the groundwork. How might the significantly reduced energy consumption in computing change the world in ways we haven't even considered yet? Think about everything from the tiniest wearable sensors to the most complex artificial intelligence systems. What new possibilities might emerge if memory becomes both blazing fast and incredibly energy efficient?
That's a great question to leave our listeners with.
It really is. Thanks for diving deep with us today.
Anytime.
And until next time, keep exploring the frontiers of knowledge.
And keep those questions coming.
We'll be here to break it all down for you.
See you next time.
Bye.